So students, in the last lecture we have seen about change of variable, and then we have seen change of order of integration. Change of order of integration, or the change of order of limit. Change of order of integration or change of the limit. Okay, this we have seen, and how to do this, that also we have seen, and at that same time we have seen some of the examples how can we solve this. Now let us see more examples based on change of order of integration. Okay, so here let us we consider one example, and this is very much important because from this example you will come to know many more ideas. So here the example is evaluate integration 0 to 1 integration x square to 2 minus x xy dA by changing the order of integration. So here you can see we want to change the order of integration. That means here you can see that the first integration is with respect to y, because these are the limits of y and these are the limits of x. So here dm is dy dx, and we want to change the order of this integration. That means we will change it to dx dy. That means first we will integrate with respect to x, then with respect to y, and for that we also require to change the limits. So the same problem is also known as change of limits of integration. Okay, and to do this we need to draw a figure, because without drawing a figure we cannot change the limits of integration. You cannot alter these limits, given limits. We can have these different limits, and for that we need to draw the figure. So here we can see that the y is equal to x square to here y equal to x square to y equal to 2 minus x, and x equal to 0 to x equal to 1. These are the limits of x, and by using these limits we will draw the figure. Okay, this is x axis, this is y axis. So y equal to x square is the equation of the parabola, you know, and this we can draw in this way. Y equal to x square. So here we will write down y equal to x square. Then y equal to 2 minus x is the equation of a straight line, and to draw the straight line we need 2 points on x axis, one on x axis and one on y axis. By joining these 2 points by means of a line we can get its geometrical structure. So if we put here y equal to 0, we get x equal to 2. So suppose it is 1, it is 2. So this is the point 2 comma 0. And if we put x equal to 0, we get y equal to 2. So here again we can get this point as 0 comma 2. Here x is 0, y equal to 2. So by joining these 2 points we can get this straight line, and this is y equal to 2 minus x. So before drawing these 2, we will just find out its intersection point. This is the intersection of y equal to 2 minus x and y equal to x there. So on a rough paper we can find out the point. If we put y equal to 2 minus x here, so 2 minus x equal to x there. So this shows that x square plus x minus 2 equal to 0. Okay, so here we can see that it has the two factors, x minus 2 and x plus 2 and x minus 1. Okay, so you can see x square plus 2x minus x means x and minus 2. So here you can get x equal to minus 2 and 1. So there are 2 points through which these two are intersecting. So here x equal to minus 2 is on this side. Actually it will meet on left hand side if we increase, but here we want this point and this is at x equal to 1. So this is the point here, x equal to 1 suppose, and if x equal to 1, then y equal to what? 2 minus 1, that means y is again 1. So this is the point 1 comma 1. Now we will trace out this point. X equal to 0. X equal to 0 is nothing but x axis, that means this is y axis, and x equal to 1. So now it is this is why we obtain this point, because here x equal to 1 will pass through this point. So if you will not find out this point, and if you draw x equal to 1 directly, then you will get confusion to find out the proper region. So the proper region is what? This line is given as a boundary, this is given, and this is given. So this is the region which we are given as a bound region. Okay. So now you observe this region and try to understand yourself. So now see here, we want to change the order of integration, and we want to integrate first with respect to x. So obviously in this region we will take a straight line parallel to x axis as we are doing always. So you can see that this horizontal line, straight line, we can draw anywhere in the region. So you can see here, if we draw this parallel line, then this left hand point is on the same curve from this point to this point. But this right hand point is changing the curve, position of the curve after this point. So here we cannot get the limits of integration directly, because whenever we consider the straight line, then throughout the region its left hand point and right hand points must be on the same curve within the region. So here we will have to divide the whole region into two parts. This is the region, first region, and this is the second region, R2 suppose. So here we need to find out the limits in within R1 and within R2 separately. So here in R1 first we will find out the limits within R1. So here the limits of x we are determining first, and the limits of y. Okay, and same situation we will have to follow in R2. That means in R2 also we will have to determine the limits of x first, then the limits of y second. So here again we will have to consider horizontal line, because you cannot do this. That in this region if you take horizontal line and here you take vertical line, this is not the process. This is the wrong process. So in both regions we will have to consider the same type of straight line. So now see in R1 here x equal to 0 because this lies on y axis. Here this endpoint lies on this straight line, which is the equation y equal to 2 minus x. So x equal to 2 minus y. Okay. Then we will find out the limits of y. So here to do this we will have to focus on y axis, where this region is lying from this point to this point. So here y equal to 1 you can see, and here y equal to 2. Y equal to 2. Okay. Then we will go for R2. In R2 you can see that the left hand point is on y axis, that is there x equal to 0. The right hand point is on this parabola where y equal to x, so x equal to root y. Okay. Now we will find out the limits of y, and for that focus on y axis where the region lies from this point to this point. You can see. Okay. So here y equal to 0 and here y equal to 1. So therefore our problem will now become integration xy dx dy plus we will have to divide the whole integration into two parts as we have determined the limits in two regions R1 and R2 separately. So in R1 the limits are 0 to 2 minus y and 1 to 2. In R2 the limits are 0 to root y, 0 to 1. Okay. And here you note that here we have given this region as R1 and this is R2. You can also give this region as R1 and this is R2. No problem is there. So now look at the original problem. Here you can see that original problem was easy to solve directly. That means by writing dy dx. Because your integration of y was y square by 2 and then the limits we can substitute, and in a single process we can do it. But here we will have to follow this in two different processes. That means two double integrals in two different regions. Why? This we must have to do. However, the original problem was simple. We will have to follow this process because here it is asked to change the order of integration, and we must have to follow this. Okay. So after doing this part, the problem is that is the integration part is very easy. You can do it very simply. So here, if you have noted this figure, then I will rub it out. Otherwise, okay. I will just rub it out. Okay. So here, this equal to, I will integrate the first one. Integration is with respect to x. So y, I will take outside. X as the integration x square by 2. X square by 2. And here the limit is from 0 to 2 minus y. And it is dy now. And same kind of situation here you can do 0 to 1. Here y you can take it outside. Integration is x square by 2. And the limits are from 0 to root y dy. Okay. So this equal to this 2 1/2 I will take outside. 1 to 2 y. Here 2 minus y whole square, because we put x equal to 2 minus y here, and then x equal to 0. This is 0. So 2 minus y whole square dy, and this is what 1/2 here again I will take outside. Y root y square means y and the dy. Okay. So this equal to 1/2 integration 1 to 2. I will just expand this one. 4 minus 4y plus y square dy, and 1/2. This has the simple integration y square, so it has the integration y cube by 3, 0 to 1, and this has the integration now 4y means 4y square by 2, so 2y square. It is 4y square. See, if you multiply this by, don't forget to multiply this by 4y square means minus 4y cube by 3. Plus here it is y cube, so y raised to 4 by 4, and the limits are from 1 to 2. This is 1/2. It is 1 by 3 minus 0, so 1 by 3. And then the rest of the values you can put, and you can find out the final answer. The final answer is equal to 3 by 8. So here you must have observed that this problem was different than the other, because here we require to divide the region into two sub-regions R1 and R2, and in both the sub-regions we have obtained the limits separately. So you note down this example, then we will go for other examples. Okay, now we go for the second example. The second example is evaluate integration 0 to 1 x to root 2 minus x square x upon root x square plus y square dy dx dx by changing order of integration. So here the solution, again we need to change the order of integration. You don't worry if you are asked, if you are given any kind of example, you can get at least 1 mark from the given example. First try to understand the problem. Here the problem is to evaluate this double integration, but not directly by changing the order of integration. However, if you want to solve this directly, you cannot do it because the integration of with respect to y is very difficult. But the integration with respect to x is easy because here the derivative of 2x is x square is 2x and 2x is already there. 2 is not there, but we can multiply this by 1 half. And already I told you that we can adjust the terms by constants, that is by numbers, not by the variables. Okay, so if you want to integrate with respect to y, you cannot divide this by 1 upon 2y and multiply here by 2y. Y you cannot adjust. You can adjust with the constants. So here we need to draw a figure. So 1 mark you can draw very easily. So here the limits are y equal to x, y equal to root 2 minus x square. Actually, if you want, you can also write the same thing as y is lies between x and root 2 minus x square. You can also write it this way because the limits can be written in this way. So and here x equal to 0 to x equal to 1. So from this we will draw the figure. It is x axis, it is y axis, you can see. So y equal to x is the straight line passing through origin in this way. This is y equal to x. Okay. And y equal to 2 minus x square. What is it? Y equal to 2x minus x square is y square equal to 2 minus x square. So x square plus y square equal to 2. So this is the equation of a circle with radius root 2. So I will draw randomly. Okay, this is the circle x square plus y square equal to 2. So this boundary is given, this boundary is given, and x equal to 0. What is x equal to 0? X equal to 0 is y axis. X equal to 1. So x equal to 1 is the line in this way, but where to draw? Because here we have also 1 point. So before drawing x equal to 1, just we will find out this point. We will find out this point. Which point is this? Because if x equal to 1 is this, then it will pass through this. If it is less than 1 is less than this one, then it will go through here. So what is this? This is the intersection of these two curves. You can see y equal to x and x square plus y square equal to 2. So we will put here y equal to x. So x square plus x square equal to 2. So 2x square equal to 2. That means x square equal to 1. So x equal to plus or minus 1. So this is the point 1. Okay? This is the point 1. And minus 1 is here, but we don't require this. So x equal to 1 is this line passing through this point. So now we will identify the region. There are so many regions you can see, but which region should we take? This boundary is given, this boundary is given, this boundary is given. So obviously this region is there. Okay. Now which kind of to determine the limits? Therefore the limits are, which kind of strip line should we take? Here the original problem is with respect to y. That means these limits have been determined by taking a strip line parallel to y-axis. But now we want to change the order. So we will have to consider the strip line parallel to x-axis. So here we will draw, but here again looking into the problem, you can see that we must have to divide the whole problem into two subregions R1 and R2. This is suppose R1 and this is R2. So limits in R1 and in R2. So in R2 the limits are suppose these are and y, x less than or equal to y less than or equal to. So here in R1 the x equal to 0 here. Here this is on this straight line, so where x equal to y. Now we will find out the limits of y here. Obviously these limits are constant. So see y axis only. So this lies in between these 2 points. Here it is 0, y is 0, and here what is y? Actually at this point x is 1. So y equal to x. So y is also 1. So this y is 1. Similarly in R2, here x equal to 0, and here this point lies on the circle. So x equal to root 2 minus y square. Okay, and the limits of y are from this point to this point to this point here between. So here y equal to 1, and here y equal to root 2, because the radius of the circle is root 2. Therefore our problem will become the first over R1, the limits are 0 to 1, 0 to y, x open root x square plus y square dx dy, and plus 1 to root 2, 0 to root 2 minus y square, x upon root x square plus y square dx dy. So here the first integration is same in both integrals, but after putting the limits they will become different, because here with respect to x and the integral is same. So I will show you one first integration 0 to 1. Here root x square plus y square is there. That means this is of this kind, x square plus y square whole raised to minus 1 half. So here the derivative of x square is multiplied this way with the bracket. So the integration is nothing but x square plus y square whole raised to minus 1 half plus 1, n plus 1, minus 1 half plus 1, that is 1 half, divided by 1 half. Okay, because we are integrating always in this way. And one more thing here is that x is there, we want actually 2x, 2 is not there, so we will divide outside this by 1 half, and here the limits are from 0 to y dy, and same thing you can do for this one in the first integration. The limits were this, and then after putting x equal to y, here we will get y square plus y square means 2y square. 2y square means root 2y, and then the integration is very simple. So the further steps you can do yourself, and then you try to find out the final value. You will get its final answer as 1 minus 1 upon root 2. 1 minus 1 upon root 2. Okay. So rest part of the example you can try yourself to solve it. So all of you write down this problem. So you complete this solution. So now let us see more examples. evaluate integration 0 to 3 root x by 3 to 1 e raised to y cube dy dx by changing the order of integration. So now see, here we will start to solve it directly. First of all, to change the order of integration, that means we are given here what is, we have y equal to square root of x by 3. Square root of x by 3 means what? Y square equal to x by 3. Okay? And we have y equal to 1. These two are the limits. Also we are given here the limits x equal to 0 and x equal to 3. Okay? So to change the limits, we will draw a figure. Then we can proceed further. So here, this is x-axis, this is y-axis. So y square equal to x by 3 is the parabola. And whose axis move towards x-axis, because here the equation is in the form of x equal to y-axis, x equal to y square. So it moves towards positive x-axis, So this is the equation, x equal to 3y square. Okay, this is the equation. And y equal to 1, we will draw it. Suppose it is say y equal to 1. Y equal to 1 is suppose here. So this is the line, this one. So it is y equal to 1. Then x equal to 0. X equal to 0 is y-axis. So this is the line. X equal to 3. So x equal to 3 will pass in this way. So where the x equal to 3, then we will not draw it randomly. But before of that, just we will look, or we will try to find out this point of intersection. So y equal to 1 we put here. If we put y equal to 1, we can get x equal to 3. So here you can see that this is the line x equal to 3 and it exactly passes through this point. So this intersected point is x equal to 3 and y equal to 1, you can see. So which region is there? This is the proper region, because this boundary is given, this is given, this is given. This is not given, so we cannot consider this as the boundary. Now we want to change the order, because here dy dx is written and these are the limits of y. So first integration is with respect to y. So we want to change the order of integration. That means we will write down now dx dy and we will integrate with respect to x. So here we will require the limits of x. Again, you remember here that if it is not written, then also you can see that e raised to y cube is there. So it is not possible to integrate with respect to y directly. So we must require to change the order of integration. So therefore, the limits now are, for the first limit is of, these are the limits of x. So y, x and y. So we will take a straight line parallel to x-axis. And here you can see that this endpoint is on the same curve throughout, and this endpoint is also on the same curve throughout. So no need to divide this region into two regions. So we can do it directly. This endpoint is on y equal to y-axis. So here x equal to 0. This is on this parabola. So where x equal to 3y square. Here the limits of y are to see. Here these are the points. It is y equal to 0. It is y equal to 1. So therefore our integration will become now 0 to 1, 0 to 3y square e raised to y cube dx dy. So integration is very easy now. E raised to y cube is constant now, because integration is with respect to x. So only dx is there. So it has the integration x 0 to 3y square dy. So 0 to 1 e raised to y cube. This is what? 3y square minus 0. Okay. Now this integration is very easy, because y cube has the derivative 3y square and it is already there. So its integration is e raised to y cube itself, 0 to 1. So if we put here y equal to 1, here we can get 1 minus e raised to 0. e raised to 0 is 1. So the answer is e raised to 1 minus 1. Okay. So all of you write down this solution now. Okay, now let us see one more example. Evaluate integration 0 to 4a integration x square upon 4a to 2 root ax and here the integrand is dy dx. So here you can see that no function is there, so it is better to solve with respect to the original problem. Directly you can solve without doing anything, but here the question is asked to find out the solution by changing the order of integration. So we must have to follow the procedure. So here this is the limit y equal to x square upon 4a. This implies that x square equal to 4ay, and second equation is y equal to 2 root ax. So this implies that y square equal to 4ax. These are the limits of x equal to 0 and x equal to 4a. So we will draw the figure now. This is x-axis, this is y-axis. So x square equal to 4ay is the equation of a parabola. So its axis extends towards y-axis, positive y-axis. In this way. So I will write down here x square equal to 4a y. This is again parabola. So x is there, so its axis extends towards x-axis, positive x-axis. So this is the parabola y square equal to 4ax. Before drawing this, here x equal to 0. X equal to 0 is y-axis. X equal to 4a. But x equal to 4a will be lying parallel to y-axis. But before drawing this, just we will find out this point. So it is the intersection of these two ones. Okay. So here y square equal to 4ax. So x, what is there x? I will put here x equal to root 4ay, or otherwise we can also do this, but to make it easy I suppose here to put value y in this one or x from this one in here. Here x equal to y square upon 4a. So y raised to 4 by 16a square, so x square equal to 4ay. Okay. So here y raised to 4 equal to 16 into 4 into a cube into y. Okay. So from this we can have the value y cube equal to, this is what, 64 a cube. And also one more value we can get y equal to 0, because this is y raised to 4 minus 64 a cube y, so y can be taken as common, so y can be 0. And so y is 0, so this is also intersected point, but we don't require, we want this point. So here, if we take cube root, then one cube root is here y equal to 4a. There are also two other roots, but they may be imaginary. So here y equal to 4a. So this is the point 4a. So here again it is given that y equal to 4a. Actually y equal to 4a means this is the point y equal to 4a. So x is what? So here I will put the value in this y square upon 4a. 1 upon 4a into y square. Y square is 16a square. So it is 4 4 is 4 and a. So again it is 4a. So this is the point 4a comma 4a. So this is the line x equal to 4a here. So now this work you will have to do on a rough paper. Okay. So which is the region here? Obviously this is the region. And now we want to reverse the order. That means reversing. Sometimes it may also be written reversing the order of integration. So dx dy. So obviously we will take a straight line parallel to x axis. Therefore the limits are the x less than or equal to and then y less than or equal to. So x is on this curve and this has the equation C, this one. So y square upon 4a x equal to, and this endpoint is on this curve where x equal to 2 root ay, and y, the whole region lies between between these 2 points. So here y equal to 0 and here y equal to 4a, you can see. So 0 to 4a, this is 4a point. Okay, and therefore our integration will now become 0 to 4a x square upon 4a to 2 root ax dx dy. So now the integration is very easy. 0 to 4a, here it is x integration x square upon 4a to 2 root ax dy. So it is 0 to 4a. Here if we put x here, 2 root ax minus x square upon 4a dy. And this is the integration very easy. 2 root a is constant. So it is square root of x. Square root of x is what is the integration? 1 upon 2 root x. You know. 1 upon 2 root x. Otherwise you can also integrate this by using this one. It has the integration minus 1 half plus 1 divided by minus 1 half plus 1. Sorry, 1 half only. Okay. Sorry, 2 root x. So this is the integration x raised to 1 half. So what is the integration of x raised to 1 half? It is n plus 1. This is not the way. X raised to 3 by 2 divided by 3 by 2. Okay. So now this is the integration 1 over 4 is constant, x cube by 3, and here the limits are from 0 to 4a, and then you can substitute the values of x. First you put x equal to 4a, then x equal to 0, and you will get the answer 16a square by 3. 16a square by 3. You will get this answer. Okay. So you can see this problem is also very simple. So now here you can observe that the part on double integral is completed. That means we have started the double integral with the simple problems. That means by given limits of integration. And in that case also first we have considered with given constant limits to both the variables x and y. Then we have considered variable limits, given limits but variable limits. Okay. Then we have seen the problems without given the limits, and when we are given the problems without given the limits, then we were drawing the figure, and then we can determine the limits by taking a straight line parallel to x-axis or parallel to y-axis, and this depends upon us to determine the straight line, as we need to know with respect to which variable the problem will become simple. Okay. After that we have seen the problems in polar coordinates, conversion of Cartesian into polar coordinates. Then we have seen change of variables, that means general changing the variables other than polar, that means xy to uv. And then we have seen change of order of integration. Sometimes it is also known as change of limits of integration, or sometimes also known as reversing the order of integration. So all of you not know this problem. Next time we will see about triple integrals. Okay, thank you.